The recording started. On the entire screen is shareable to you. It may visible to each one of you. Please tell me what is the X bar and Y bar for the yesterday's numerical. I have already given you this numerical. The statement of numerical is already given to you, and I have told you to calculate the values for X bar and Y bar. So, if you have done with the calculations, tell me the calculations for X bar and Y bar. कुणी केलेत का calculations? ऋतुजा, निलेश, none. Okay, no issue. Maybe this is the last lecture for unit number 3. Tomorrow I'll start unit number 4. So the yesterday's numerical beam has the beam having the channel section subjected to bending moment about x-axis. Calculate the thickness. So to identify T is to be identified. Okay, let me duplicate the slide. Let me put to find what is to be identified. T is equals to question mark. Calculate the thickness of the beam. Okay. Then the bending stress at the top and the bottom is 7:3. Considered beam as a simply supported beam. So the stress in the beam is 7:3. So what is given to us? What is this? 7:3 is what?
Sir, sigma.
7:3 is what? Sigma. Which sigma? Perfectly correct. You are right.
Top layer and bottom layer.
The bending stress in the top, that of the top and the bottom of the beam is 7:3. So this is a simply supported beam. In case of simply supported beam, which stresses are at the top and which stresses are at the bottom?
Compression and tensile.
Compression and tension. So the sigma C upon sigma T is given to us. That is, where it is sigma C and sigma T. So this is nothing but sigma C. Let's see where it's sigma C. Sigma C and sigma T is given to us. Sigma C divided by sigma T is equals to 7:3 is given to us. Very good. So these things are given to us. To find is T is to be identified, and only given is this. Let me reverse the order as we are putting given first to find second, and the third one is the geometry is given to us. The C section is given to us, or channel section is given to us, 600 by 250 by 250, and T is to be identified. Now moving ahead to calculate the T. As usual, the first agenda is to identify the value of X bar and Y bar. So let us move to calculate the X bar and Y bar. So if I draw the section and the probable bending moment diagram is like this. The top layer is subjected to compression, the bottom layer is subjected to tension. Okay, so this is YC and this is YT. Already the value of sigma C is given to you, the value of sigma T is given to you. So I can write down the equation as sigma C upon YT is equals to YC upon YT. So sigma C upon sigma T is equals to YC upon YT, and T is to be identified. Perfectly correct. So simply we can write sigma C upon YC is equals to YC upon YT is equals to how much? Is equals to Sigma c upon sigma t is equals to yc upon yt is equals to how much? Is equals to how much? Hello, am I audible to
7
you?
by 3.
7 by 3, simple. It's good. So we have to apply similarity of triangle. Sigma c upon sigma t is equals to yc upon yt is equals to 7 by 3. So simply we can say yc upon yt is nothing but the 7 by 3. Okay, so we have the value of yc and yt. From NA, one is yc, one is yt. So please tell me yc plus yt is equals to how much? Can anybody tell me? Yc plus yt is equals to how much? Total. Yc plus yt is equals to how much?
250.
Perfectly correct. It is 250 total depth. Total depth is 250. So yc plus yt is equals to 250. So if I rearrange this term, so the equation becomes yc is equals to 7 by 3 yt. This is over here. This is the first part. So this part, first part is this. Second part is I'm just rearranging the term yc upon yt is equals to 7 by 3. So yc becomes 7 by 3 into yt here. Yc is equals to 7 by 3 by t. But just right now, Rushi has told me, sir, yc plus yt is equals to 250. So it is yc plus yt is equals to 250. So I'm just putting the value yc plus yc is equals to 7 by t or 7 by 3 by t plus yt. So the addition would be equals to 250. So 3 yt plus 7 yt is equals to 10 yt by 3 is equals to 250. So the value of yt is equals to 250 into 3 by 10. So the value of yt is equals to 75. My question is, if the value of yt is equals to 75, yc is equals to how much? If the value of yt is equals to 75, yc is equals to how much? If the value of yt is equals to this much, what is the value of yc?
सर वाईट
हाँ,
250 मधून YT मायनस केले की YC ची व्हॅल्यू भेटेल.
perfectly correct. So that is I have done over here. So yc is equals to 250 minus 75. Perfectly correct, Rutuja. So the value is, so the value you have told me the equation yc is equals to 175. Perfectly correct. So I have yc, I have yt, and now directly moving towards. See, the yt and yc both are with me. My next question to you is, what is the value of y bar? Divya, what is the value of y bar? Divya is there? She is there or not? Divya is there or not? Yes, no. Divya, unmute yourself and talk to me. If the yc is equals to 175, yt is equals to 75, what is the value of y bar? I'm not getting you. You can type your answer in the chat box. No issue. What is the, if yc is given to you, yt is given to you, so I'm expecting the value of y bar. Anybody else? The diagram is there in front of you. If yt is equals to 75 and yc is equals to 175, what is the value of y bar? आहे का कोणी? Anybody else? ऋतुजा, चव्हाण. Nilesh Kaur is saying 125. And anybody else? Rushikesh, Nilesh, Rushikesh is saying either 125 or 75. Okay. So the answer is y bar, we are considering y bar from the bottom. So from the bottom, we have the yt. So the value for yt is nothing but 75, which is our y bar. So y bar is equals to 75. Simple. Y bar is 75. We know y bar, we know yt, we know yc. Now x bar, as usual. Mirror image, if it is mirror image, it is divided by 2. If it is not, then we have to apply the formula. But here it is a mirror image, so I am calculating the value of x bar as directly 600 divided by 2. It is 300. Mirror image. Okay. Then, now I know the value of y bar. But if I don't know the value of y bar, as it is a symmetric section, in that case I have to apply the formula, that is a1 y1 plus a2 y2 and so on for 1, 2 and 3 sections divided by a1 plus a2 plus a3. So right now my agenda is to identify the value of a1, a2 and a3, y1, y2 and y3. Let us find out. A1, it is a1, so it is 250 into t. This is the t. A2 is 600 into t. A3 is equals to 250 into T. A1, A2 and A3. What about Y1, Y2, Y2? Y1, it is 250 by 2. Y1. Y2 is T by 2. Y3 is 250 by 2. So Y1, Y2, Y3 we have, A1, A2, A3 we have. Okay, so we have A1, A2, A3, we have Y1, Y2, Y3, and we know the directly the value for Y bar. But in between all the formula, only the value for T is unknown. The term for t is unknown, and that is our agenda to identify the value of t. Let us move on. Y bar is equals to 75. Y bar, that this is the formula for y bar. This is the formula, and that is the term that we already know. Now putting the value. This is a1, y1, a2, y2. Let me separate out this. Okay. All the formula is written over here. Now, for you, my question is, if y bar is given to you and the value of a1, a2, y1, y2 is given to you, can you identify the value of t? Yes, you can. Please go ahead, calculate the value of t and tell me the answer. Let me do it. 75 into a1, y1, a2, y2, a3, y3 divided by a1 plus a2 plus a3. So 250 into 125 is 31250t. 600 minus 2t into t, it would be 3t square minus t cube. Then 250t into 150, that is 3125t, 250t divided by this. So moving all around, the equation is, my equation is coming this, and the value for t is 400, t2 is 0, and t3 is 50. So please go ahead, calculate this equation into your calculator and tell me the value of t. It is right or wrong. Go ahead and calculate the value of t and tell me the value of t, it is right or wrong. Meanwhile, if anybody is having any doubts, you can ask me. Very simple numericals, huh? No issue. Those who have joined today's first, na, so they may face the issues. But those who are regular in the class, na, they come to know what is exactly going on over there. Please tell me the value of t. Rushi, Divya, Anjali, Harshal, Chitte, Golab, Kalyani, Krishna, Kunal, कुणाल कोठावदे, मनमाड, मयूर शहा, मंगेश वैराकर, निलेश कुवर, ऋषिकेश आहेर, ऋतुजा गंगुर्डे and सौरभ देवरे. Please go ahead and tell me the value for T. You have calculated the value of T or not. Expecting the answer, whether the 50 is right or wrong. Anybody else? Divya, Rushikesh, huh. Divya is saying 50 is the answer. Please give me the confirmation whether Divya is right or wrong. Anybody else? Expecting one answer, more one answer. Shah किधर है? Shah is there or not? Shah,
Yes, sir.
आज डाउट नहीं है कुछ?
No, sir.
पक्का?
Yes, sir.
टेल मी. अरे आपकी तबीयत सही नहीं है?
Yes, sir.
अच्छा चलो, ये दिव्या का आंसर सही है कि गलत है इतना बताओ मुझे. One, I'm expecting one more answer. Rushi, Nikam. Manav Shah, MS 125. It is absolutely wrong answer, Shah. 125. You have to put everything properly. Look at the equations. You have to properly put the equations. Until and unless you will not, the answers will not coming properly. This is the equation.
हॅलो सर,
हाँ ऋषिकेश,
150 कसं काय आलं?
कुठला 150?
ही 82500 T मायनस 150.
कुठे?
हा ते
8250 T minus 150 ना.
हा
सी
150.
याला इथे यायला लागेल पहिले. हा जो आहे ना, हे इक्वेशन, हा जो आहे 112T² मायनस 2T² याला इकडे घेऊन आलोय. 75 इंटू 11, हे इक्वेशन समजलं का इथपर्यंत? इथे फक्त हा जो डिवाइडेड बाय होता इथे याला मल्टिप्लाय केला. 75 इंटू 1100T मायनस 2T² इज इक्वल टू दिस. क्लिअर आहे? हे इक्वेशन क्लिअर आहे? इथपर्यंत क्लिअर आहे का? हॅलो.
हो सर.
हा आता 75 इंटू 1100 का.
हा 82500.
हा मग हे आलं 82500. क्लिअर आहे? आणि 75 इंटू 2 इट इज 150. 75 दुने 150. आणि हे
Sir,
इक्वेशन
T value of T.
किती कितना आ रहा है बोलो ना कितना आ रहा है मानव ठीक आहे ऋषिकेश इथपर्यंत
हो सर.
बरं ठीक आहे the equations is given in front of you everybody please solve it and if have any query ask me I'm there for you. I'm expecting one more answer so that I have to go. Nilesh is saying 150. Okay, Nilesh. Very good. The right answer. Those who are facing difficulty with the answers, please do it at your level. The answer is 50. It is the right answer. The first comer who has given the answer me is Divya. Now we are moving towards the second. It is shear stresses on the beam. So as bending failure, we have the formula that is m by I is equals to sigma by y is equals to e by r. Similarly, in bending, the beam will not fail only because of bending; it will because of shearing too. So the formula for this is tau is equals to Fa y bar upon Ib. Sometimes in some books it is mentioned that F is equals to S or Sa y bar upon Ib. So irrespective to the book you refer, you can write as Sa y bar upon Ib or you can write it down as a Fa y bar upon Ib. Please write down Fa y bar upon Ib. Try to understand the terms when the shear stresses in the beam induced or when the beam is subjected to bending, it fell because of bending as well as the shearing. That's why the shearing stresses are also induced into the beam as the failure is due to the deflection of layers from the ME. Okay, so let's see the different terms and their meaning and units. Tau is your shear stress in the beam and it has unit as a Newton per mm square. F is a force or shear force has a unit Newton. Force has a unit of Newton. Then area above or below. So it is area. So it has a unit mm plus 2 that is mm square. Why it is a distance of centroid of the area. So it is a distance. So it has a unit in mm. So I is mi of complete section. So it is as unit mm plus 4 and it is the width of the layer. So it is width of the layer under consideration. So it is mm. F is the shear force, shear area, distance of layer or distance of layer from the centroid. I is the moment of inertia and B is the width of the layer. So tau is equals to F bar upon IB. Let us have a look of simple numerical and then we go for the excellent level or difficult level. The cross section of the beam is a rectangle section 60 mm into 80 mm. So the 60 mm by 80 mm rectangle section is given to us. The maximum shear stress in the section is 45. So this is tau is given to us 45. So calculate shear stress in art section 40 mm above NA. So they ask us to find shear stress 40 mm above NA. So let us draw insert line where it is line. Outline, picture. Copy this. So they ask us to identify the shear stress 40 mm above NA. So this is NA, and from here 40 mm above we have to identify the shear stress, and 20 mm above NA. 40 mm above NA and 40 mm, 20 mm above NA we have to identify the stresses or shear stresses. As usual, we go for first X bar calculation, Y bar calculation, that is the location of centroid. So X bar is 60 by 2, that is 30. Y bar is 80 by 2, it is 40. The first. Now we have to calculate tau. Tau 40 above NA lies at. So here already we have the NA at 40. Okay. So from here to the end, 40 mm above. So they told us to identify the tau at extreme layer. That is lies at 40 mm, which is at the extreme layer. And as in case of bending stress, the bending stresses, that is bending compressive stress and bending tensile stresses are at extreme and are maximum. Similarly, the shear stresses at extreme ends are zero. Make a note. Make a note. Shear stress at the extreme end of the element is zero, and it is maximum at NA. Its intensity is going on increasing from extreme end towards the NA, and at NA it is maximum. The second, tau at 20 mm above NA. Tau at 20 mm above NA. So from here to 20 mm above NA. So this is the section over which we have to focus on the shear stress calculation. Okay. Tau NA. Maximum tau located at the NA, that is at the neutral axis. Tau 20 mm above NA, it is equals to FA y bar upon IB. This is our standard formula that I have shown you at the initial level. SA y bar upon IB. Okay. So at 20 mm, FA y bar upon NA. So let us move towards the calculations of I, B, F, A, and Y bar. So that will have a value of tau NA or tau 20 mm above NA. But if I wish to identify the value of maximum tau, if I wish to identify the value of maximum tau, the formula is 1.5 into force into BD. So shear force upon PD. That this is F is shear force upon B into D. The section B into D. Let us put the value. Tau max is equals to 1.5 F upon BD is equals to 45, as the value of maximum shear stress is 45, which is already given to us. The maximum shear stress is in the section is 45. It is tau is equals to, I can write tau max. It's already given to me. And the formula is this. So the equation become 45 into BD into 1.5. Ultimately, we'll get the value of force. ultimately we'll get in the value of force. Which is equals to 144 into 10 raised to 3 Newton. This is the value of force, this value. I have calculated the value of F. Now second, how much area? So I have to focus on the area. How much area it is subjected to above the layer. So 80, this is 80. And what is A, what we have mentioned A? Area above or below Na. Area above or below Na. So this is the area above or below Na. This is the Na. So 60 into 20. So 60. This is 60. 20 is the area above Na. This 60 and this is 20. Which sections we are talking about? Above 20 mm. So that highlighted area having width of 20 and depth of width of 60 and depth of 20. So it is 60 into 20 is the area. Okay, so F we have calculated, A we have calculated. Now the point is Y bar. So this is the section, and where is the its centroid located? Its centroid is located at their center point. So this 20 plus 20 by 2. Let us see this 20 plus 20 by 2. F we have identified, A we have calculated, Y bar we have calculated, I. So what is the moment of inertia of complete section? I is equals to BD cube by 12. So B is 60, D is 80. So BD cube by 12. Let us see I, moment of inertia of complete section. So it is I is equals to BD cube by 12. B, D cube, 60 into 80 cube by 12. So it is this. F A Y bar upon B is a 60. So my question for you is, what you have to do? First, take this. I guess you come to know that the shear stresses at the extreme fiber is always equals to 0. And what is your agenda? You have to go and you have to calculate the value for what you have to identify. You have to identify the value of tau 20 mm above Na. Go ahead and tell me the value for tau 20 mm above Na. All the values are given to you. F is there, A is there, Y bar is there. Where is Y bar? Y bar is there, I is there, B is there. You have to calculate the things and you have to tell me the answer for shear stress induced 20 mm above Na. And meanwhile, if anybody is having any doubt, you may can ask. Hello, am I audible? Rushikesh, Rushikesh, Nilesh, ऋतुजा, गांगुडे,
Yes, sir.
हाँ, काय तिचं नाव? दिव्या, दिव्या, hello, is there or not? I don't. Divya. Okay. So the task for you is go ahead. The values for the things is given to you, and you have to tell me the value of tau 20 mm above Na. Saurabh Devri is saying 33.75. Anybody else? I'm expecting one more confirmation.
Yes, sir. 33.7.
Okay, let me check the answer. The answer is with me is okay. So the answer you have given me is perfectly right answer. It is it is is equals to 33.75 MPa shear stress. Good. The numerical for you. The figure shows the cross section of subjected to shear force of F is given to you. Draw shear stress distribution diagram. Given shear stress, shear force is given to you, and they told us to identify the shear stress distribution diagram. When we have to calculate the shear stress distribution diagram, we have to plot each and every points, each and every point at each and every sections, as the intensity of the shear stress distribution is varies from extreme end to the NA and from NA to extreme ends. So the first target is to calculate X bar, Y bar. The formula is tau is equals to FA Y bar upon IB. So y bar is given to you, or y bar is mentioned in the formula, so we have to calculate the X bar and Y bar. F, A, Y bar, then I and then B. So the first target I am giving to you is calculate X bar and Y bar, and then calculate the I, moment of inertia, and then I will tell you how to find out the value of shear stress at extreme end, shear stress at junction, shear stress at NA. So the first target is to you is go ahead and calculate the value of X bar and Y bar. Can anybody tell me what is the X bar for this? Can anybody tell me what is the X bar for
X bar
this?
100 by 2.
X bar, very good, Rishikesh. What about Y bar? How to calculate Y bar?
A1 Y1 plus A2 Y2
Very good, very good. What is
divided by
A1?
A1.
What is A1? 12
12.
into 8, 12 into 88. Very good. Y1 is 100 into 12. A1, A2, Y1, Y1. What is Y1? What is Y1? Rishikesh, what is Y1? Nikam, Rutuja, Chauhan, Divya.
88 by 2.
Very good. 88 by 2. And what is Y2?
88 plus 12 by 2.
Perfectly correct. Nice. So go ahead and calculate the value of X bar, Y bar. And next question is how to calculate IXX1 plus IXX2.
A1 Y1 plus A2 A2 A1 Y1 A2 Y2 divided by A1 plus A2
कसला फॉर्म्युला आहे तो?
IXX.
मूर्खा, तो वाय बार काढण्याचा फॉर्म्युला आहे तो IXX म्हणे.
IG1 plus
A1
A1
H1
H1.
Perfectly correct. Perfectly correct. Nice, nice. So the formulas are there with me. You have to calculate the values of the. Let me. See, some calculations I have done already. What you have to do, you have to tell me whether these calculations are right or wrong. Go for the calculations and tell me whether. So tell me y bar is equals to how much first? One. Okay. Go ahead and calculate the value for y bar. Tell me the value for y bar. See, calculation of X bar, Y bar, and calculation of I, that is IXX, is a homework for you. Today I'm going to stop over here. If anybody is having any doubt query, you may can ask right now. And in the next lecture, I'll show you how to identify the shear stresses induced in the different sections of the T section. If anybody is having any doubt query, please ask me. Anybody? If no, then I have shared a link for the attendance sheet in the chat box. Those who have not yet given the attendance, please fill the attendance sheet. And once you have given the attendance sheet, you may can leave the session.
सर
हाँ, tell me.
सर वो कल की रिकॉर्डिंग और आज की रिकॉर्डिंग मिलेंगी क्या सर? आपने कल बोला था यूट्यूब चैनल पे. डालेंगे।
मैं डालता हूँ, मुझे व्हाट्सएप पे हाई कर दो, मैं आपको शेयर करता हूँ, ठीक है?
यस सर।
व्हाट्सएप पे मैसेज कर दो कि सर ये दो, मैं डाल देता हूँ, है ना?
यस सर।
Good, good, good. So somebody has given me the value for y bar is 70.59. Let me check.